the first one is about minimizing cost. So you are, fortunately at this point, at this stage, they tell you the model. They make it really easy for making wedding cakes. Here's the model. It's important to know what X and Y stand for. So Y stands for the total cost for the baker for making wedding cakes. So that's Y. And X is the number of cakes you're preparing. So it changes. Does it always increase by the total number of cakes? Well, it's parabolic, so not necessarily. Does it open up or down? Okay, so good. So in what form is this in? It's in standard form. A is positive, it opens up. So what I'm looking at, I need to show you so it makes sense of what you're looking at. You can write on your paper, so you'll be done with the hardest problems. So it opens up, so this point, what does X represent? The number of cakes. And what does Y represent? The cost. And so this, when we say what's the minimum cost, this is what we want to minimize. And notice the question makes sense because it says the word minimize, and it's a parabola that opens up. So you would expect the vertex to be the minimum. Okay, so if we find this vertex, it's telling us this many cakes will give us this lowest cost. That's what the vertex means. So it actually, we want to minimize Y. So we want to find what this is that minimizes Y. So find the vertex and the axis of symmetry. So we know how to do this. We do X equals negative B over 2A. The opposite of B is positive 12 over 2A. So it's 12 over 2 times a half is 1. Okay, so, well, that wasn't bad. The X coordinate is 12. So that means that 12 cakes is going to give us the minimum cost. And so what is the minimum cost? Well, we plug in 12 into the equation because that's how you find the Y coordinate of the vertex. So it's going to be 0.5 times 12 squared minus 12 times 12 plus 150. So that will be our minimum cost. So that'll tell us how many cakes should be prepared each month to yield the minimum cost. Well, we already know that's 12. So I need you to answer at least with units, 12 cakes. We found that in part A. The equation of the axis of symmetry is just X equals 12. And then the vertex, you just need to evaluate this for Y to figure that out. So are there any other questions? I'm going to let you finish it, use your calculator and finish the problem, but we basically, that's all there is to it. Not that hard, huh? Right, when you're given the model. So now let's look at this one. This one's a little trickier. Maximize. So what do you expect the shape of the parabola to be if it's maximized? Good, you're drawing it, guys. So we're looking for this vertex right here, and we want to maximize revenue. So let's look at what the question says. So if right now it's selling, a sports store is selling 50 mountain bikes per month at a price of $220. If you decrease, right, this is a very real business application. If you decrease the cost by $20 per bike, then 10 more will be sold. And so we want to figure out what the how do we get the most money? So what's the number of bikes? So Y is going to be the revenue. It's really, you know, we always talk about X and Y, but we never talk about what they mean. Oops. So let's use the space over here. So Y is the revenue. X is the we want to know what price, maximum revenue. So this is the price. So our revenue Y equals, we want to multiply the cost, an expression for the cost, times an expression for the number of bikes. So we'll sell about, so the number of bikes is 50, but we can sell, for each $20 decrease, we can sell 20 more bikes. 10 more bikes, sorry, 10 more bikes. So we're right now we're selling 50, but we can sell 10 more. So I guess actually X is going to be the number of bikes. The cost is going to be, right now we're selling them for $220, but for each price decrease, each price decrease of $20, we can sell 10 more bikes. So this is actually, X is going to be the number of price decreases. That's what X is going to be. This is the number of price decreases. And Y is going to be the revenue. So this is the quadratic equation, and if we want to write it, what form is it in now? It looks more like intercept form. Yeah. We want it in standard form, so we're going to just distribute. We're going to FOIL it out, and then we'll have it in standard form when we can find the value of the vertex. So you just multiply 220 times 50, 220 times 50, 11,000. 220 times 10 plus 2200x. So we distributed the 220. We're going to distribute this, so minus 1000x minus 200x squared. I just FOILed it out. I get 4 things. Now I'm going to write it in order in standard form. So I have negative 200x squared. Combine these. So that's plus 1200x plus 11,000. So now that's for 25. That's in standard form. And we just need to know what the vertex is, so we do negative b over 2a. So negative 1200 over negative 400, and we get, the zeros just cancel, so we get a nice 3. It's nice when the answer comes out to be something simple. So we basically want to do 3 price decreases. So what price would it be to maximize the revenue if we do 3 price decreases? So we would do $60 less. So good, I think that's right. 220 minus 3 times 20. So subtract 60 from that. So 160. Is that what you said? Yep. So $160 is going to be the maximum revenue that we can get. That's the breaking point that we can get if we charge customers. I don't think it asks what we're charging, but we're charging $60 less because we're going to sell more of the mountain bikes.